Hello everyone, here is Kostas, Sierra Victor 3 Oscar Romeo Alpha from qrp.gr, and today I'm gonna build a small splitter for another project of mine, and I will use this splitter to split a local oscillator between two identical outputs isolated between them. I have found two circuits on the net. I think both are from DC4KU. This circuit here, I'm talking about this part only, which uses a Wheatstone bridge as a combiner and splitter. It can be used as a combiner in this case, and the output is here, or as a splitter if you feed an input signal at one of the ports. You take the output from you take two identical outputs but isolated between them from the other two ports. So I have found also another diagram and here is a curve for this diagram. The vertical axis is the decibel of attenuation between the inputs, the output, and the isolation between these, and the horizontal axis is the frequency. So we're talking about only from the beginning to about here, about 30 megahertz is what I'm interested in. So it should give a good 45 to 50 decibels of isolation between the output ports. I don't know how clear you can see this diagram. The most here's a 100 nanofarad capacitor. I have increased that to 100 nanofarads, but it was 10 nanofarads in the original circuit. Here's another 100 nanofarads, which was originally 10. Another 100 nanofarads, which was also originally 10 nanofarads. And here are the 50 ohm resistors. This is the load resistor. Here are the 50 ohm resistors, the three resistors. And here is the transformer that is composed, that is wound onto an FT37-43 core. And it's wound with 8 windings, 8 bifilar windings. So there are two wires twisted together, and then you wind 8 turns onto this core. And the wire diameter is about 0.5 millimeters. And this is another version of it. I noticed quite a few differences in the way this is represented here. First of all, it says FT37-72, which does not exist. This core does not exist, so that's probably a mistake here. And also there are different ports for the input and for the output here. And but here the input and output ports are different labeled. So I'll try to figure out which of the two circuits are actually correct as I go on with the experiment. But first I'm going to wind this transformer, which is the most critical part, the most hard to build part of this splitter. And then I'm going to build the whole circuit and test it. So here are all the components required. Here is the core, an FT37-43 core. I'd like to mark my ferrite cores using permanent markers. If you can see, I have already marked this, because if I accidentally mix them with other cores, I wouldn't know otherwise whether they are of 33 material or 61 or another ferrite material. So we have here the three 100 nanofarads capacitors, the core, And for the 50 ohm resistors, I'm gonna connect two parallel resistors for each, two parallel 100 ohm resistors for each 50 ohm resistor required, just to make them precise at 50 ohms, because otherwise you have to go either with expensive 1% or less resistors, or to get exactly 50 ohms, or you can go with the cheap ones, but you get 47 ohms or 52, I think, ohms is the next value. So the best way is to combine 200 ohm resistors and make a precise 50 ohm resistor. Just connect them in parallel. Of course, we need a piece of wire, an enameled wire, about 0.5 millimeters in diameter, and this particular wire I have here is 0.54 millimeters to be precise. So let's get started. So first thing is to build the transformer, and for this we will need a piece of the piece of enameled wire we have, about 35 to 40 centimeters in length, and I will half it into two. Just put the edges of it together. Go to the other side. This is the middle. And I will cut this here. So they are about the same size now. And now, to preserve the balance in this transformer, I believe it's important to preserve the balance in this splitter, and it does matter if we do what I'm going to show you now. So to preserve the balance, we will need to twist these two wires together. So to twist them, I hold them side by side. I make the first twist. Let's do it from the other side, so that I can twist them right-handed. I mean clockwise. And we start twisting them together. When you twist them, make sure, let me adjust the camera a bit. When you twist them, pass your hands between the turns, between the windings. I don't know if the camera can zoom here. Yes, pass your hands here and give them a twist. I have there are other methods as well. You can use a drill to do the twist. And the pliers. But if the wire diameter is quite large, you shouldn't have a problem of doing it by hand.